Hello, my name is Aiman Setiawan and I will explain about MySQL part of this project. So for the machine learning, we have the test set and learning set. We use the analog values for test set and measurement data for learning set. Basically, each data is different time set for each time set. It consists of data of 9 buses of voltage and voltage angle, and we will import of the data to Java. Let's see the main program. First, we create array list with specific types to store the data, and then we import the data. We create a class called import with the input of username, password, the array list we want to use. Then we get connection. We use the subtables, and then we create the loops, and for each iteration it stores the data from the MySQL to the array list. So we store the data for the measurements, the learning set, the analog values, the test set, and also the substation data.
Computer application for power system assignment 2, and I'm Harold Spanji will explain this part. This is the main program. So we want to start the value of username and password. How do we use it? We use J option pen. We will enter our SQL username and password and save it in username and pass, and it will use later on this part to import the SQL and other things so we can access our database subtables. And then this is how the program runs. This is the GUI display that we have, and if we want to show the k-means clustering, this is the result. If you want to show the KNN classification table, this is the result. Okay, go back to the business. Well, I will KNN. And I will explain to you about Canary snake bird, the part 2 of this assignment. So this is the result. This is classification summary from the KNN values that we get from analog values. This is the timestamp that belongs to cluster 1. This is timestamp belongs to cluster 2, 3, and 4. And how do we make it? So we make a new array list called learning set. It contains learning. What is learning? You can check the class learning. It contains number and set. Set is a set of voltage and angle at corresponding bus bar, and the number is the number of iteration at which iteration. So we store that value on the learning set with tag, and then we also from the previous k-means clustering, we get cluster 1, cluster 2, 3, and 4, and we get the size. We make a for loop for from zeros up to the -1 of the cluster size, so we get the cluster size, and we store the value of y and z, what is on this w, and then we will add the value of w. So what is the value of the w? It contains y and z. Y is the set of voltage and its angle at all the 9 bus, and then the z is which cluster it's belong. So it's belong to cluster 1 because we get from the cluster 1. So we store the value z is equal to 1 integer, and y is set of voltage and angle. And the same goes to cluster 2, 3, and 4. And then we make an array list. We initiate result 1, 2, 3, 4, and GUI KNN 1, 2 up to 4. This is we will use it later. And then we make an array. We make an for loop for from 0 up to 19. We want to store the value of analog value that we get from subtables from SQL. So from that value, as I explained before, we will make it that the voltage angle start from 0 up to 8, and for the angle of the voltage from 9 up to 17. And then we initialize distance as 0 and equidistance distance as 0. And then we make also a class called results that we also save this on the results. The result is here. The results will save number of iteration, which iteration that it will get, and the distance. The distance is we get from this main program. So we also make a for loop again for learning set size. If I said before, learning set is the value of voltage and angle that we get from previous K-means clustering. So there are 200 value, and we will make it VL1 is voltage at bus 1, AL1 is angle of the voltage one at the bus 1, and then so on. And then we calculate the distance. Basically, we subtract the voltage set between the analog value that we have and the K-means value, that measurement K-means value that we have. So we multiply with the cos of the angle and sin with the angle to get the real and imaginary value of them, and then after that we power it with the factor of 2, and then we sum up all of the 9 bus value, and then to know the equidistance distance between them, we just add the square root of the distance, and then we got the equidistance distance. We store that equidistance distance on the result value that we have before as an array list. So what do we save? Equivalence distance and CLS. CLS is corresponding learning set. So we get which cluster this learning set belong. So we get the equidistance distance and to the equidistance distance to the corresponding learning set and which cluster this learning set belong. And then we sort this value, we sort this equidistance distance, we sort this from the lowest up to the highest. So from the short distance up to the far distance. So we use this sort comparator. This is the method that we use to sort things from the shortest distance up to the farthest distance. And then after we got the result from the shortest distance up to the farthest, we initialize CL1, CL2, CL3, and CL4, and then we make for loop once again. We make a for loop up to from 0 up to 4. What does it get? So we choose 5 as our k-nearest neighbor. So we will take the number. What is the number? The number is which cluster it's belong to. If it's belong to cluster 1, CL1 plus plus will add it to the CL1, and if it belongs to cluster, it will be CL2, and so on. And then we make an if statement once again. So at the end of the day, we want to compare which has the more value. So if from the 5 distance it is closer, more of it in this cluster 1, then cluster 3, and then cluster 2, and then cluster 4, it will at the result cluster 1. So and then we will take the time of the measurement, and then we also make a new list, GUI and one list. This is used to make the table later, and then we also make, there is 2 column. The first column we take is the number of time, at which time it is condition, and then the second is which cluster it's belong to, because it's clear from here that it's belong to cluster 1, so we just type 1 as a double, and then type to canon 1 list, and the same things, the same logic applied to cluster 2, cluster 3, and cluster 4. And then after that we sort the results, and then we print the result. So this is how we make it. Because we have the value on double, we changed it into string first. We change it into string so it can be displayed on the table. And then later this is...
My name is Ayman. I will explain how we did the data clustering by using K-means method. So as explained before, we have obtained the learning set data and test set data and stored it to an array. Then we take those data for the K-means. So we will use the learning sets. So we take the voltage and voltage angel and store it to two-dimensional arrays. For these arrays, we have 200 of rows because we have 200 different state of times, and also 18 columns because we have system with 9 buses and with different values of voltage and voltage angel. Then for the K-means, we set 2 cluster centers because we will do the iteration of the clustering, and the iteration will done after the distance between the old cluster center and new cluster center equal to 0. We set the initial value of the cluster centers. For the cluster center number 1, we take the value of the 40 and then so on. We also create an array to store the results. For this array, we will store the state of time, and also we will state the number of data. And for this cluster, we only store the state of time because we want to sort it out easily. And then iteration begin. In this loop, we also have this loop to iterate 200 of data because we have 200 of learning set. In this loop, we give initial value of the distance and Euclidean distance, and then we start to calculate the Euclidean distance from the learning set to the different cluster centers. So because we have value of voltage and voltage angel, we treat the data as a complex number. So we calculate the real part of the data. So V1 cosinus voltage angel of 1 because it is represent the learning set, and V2 cosinus voltage angel 2 is present the test set. So we take the square number of it, and then we accumulate the values, and then take the square value to calculate the Euclidean distance of the learning set to cluster number 1. We did the same things for all the cluster centers to cluster center number 2, number 3, and number 4. And then we take the value of the learning set and store it to one-dimensional array. After that, we compare all of the Euclidean distance. So we have 4 if function because we have 4 different clusters. So for example, if the Euclidean distance of the learning set to cluster center number 1 is the smallest, and then the data set, the first data set, will be added to cluster number 1. And it also applied for the other cluster number 2, cluster number 3, and cluster number 4. After that, we get the mean values of the clusters. So for example, the cluster number 1, we calculate the mean value of it and then set it as the new cluster centers. We also did the same things for cluster number 2, number 3, and number 4. And then here we initiate the residual value. Residual value will be presented as a distance between the old cluster centers and new cluster centers. and then we calculate the distance, the residual one, the distance between old cluster 1 and new cluster 1, and so on. And this the if function. If the residual of cluster 1, cluster 2, cluster 3, cluster 4 are equals to 0, and then checks equal to false, it means if check equal to false, break. It means that we will get out from the loop and the iteration is done. If the iteration is not done, and then we reset value of these arrays which store the final results, because we only want to store the final results after the iteration is done. Here we sort the values of the data belong to cluster 1, cluster 2, cluster 3, cluster 4, from the smallest to the highest. So here is the final result. This is the final result of the k-means of data clustering. So we have the data which belong to the cluster number 1, present the time, also the cluster number 2, number 3, and number 4. Okay, that's it.